A restaurant wants to study how well its salads sell. The circle graph shows the sales over the past few days. If 5 of the salads were Caesar salads, how many total salads did the restaurant sell? So, what are we trying to find? Here's our question mark right here. So it says how many, this is our question word. So the question that we want to answer is how many total salads? So we're trying to figure out what is the whole. So this is what we're trying to find. And then the given information that we have to find that is this circle graph over here. And we also have in the question or in the prompt, it says 5 salads or Caesar salads. So we know 5 salads is equivalent to Caesar salads. So you need to know your percent formula. What is the percent formula? Well, a percent is a part to whole ratio, so it's a fraction, a part to whole fraction, and you basically just want that fraction to be equivalent to per 100. So it's going to be the part percent over the whole, or the part over whole is equal to part percent over the whole percent, and the whole percent is always 100. So we're going to substitute these numbers in. So 5 of the salads were Caesar, so I'm going to put 5 in for my part of my ratio. So the formula have a ratio side. So this is our ratio side, our part to whole ratio, and this side represents our percent. One side of the equal sign represents the ratio, the other side represents the percent. So this 5 is represented by the Caesar salad. I'm going to put an S. And then I need to put the whole. It says the total number of salads, so I don't know what the whole is. I'm going to put a variable there. And since I have an equal sign in the middle, I need to find the percent that's equivalent to the whatever is across from it. So I have 5 is represented by the Caesar salad. So the percent that I need over here needs to be Caesar salad. So you have to put 25% in because 25% represents the Caesar salad. If we put the percentage for garden or put the percentage for this one, we'll get the wrong answer because the equal sign means equivalent to. So if we have five Caesar salads here, we need the percent for Caesar salads, which is 25 per our division line cent. So once we find out what the value of X is, we'll have the total number of salads. Now in this case, you can use equivalent fractions because how do you start with 5 and end up with 25? You would just multiply by 5. And since we started here, we need to come down here and do the same exact thing. So we're going to multiply X by 5, but I can't do it that way. So I need to start over with my known percent, and I need to go the other way. So 25 divided by 5 will give me 5. So I need to start here, and 100 divided by 5 will get me my answer for X. So 100 divided by 5 is going to be 20. So the total number of salads is 20 salads. So now that we know the total number of salads, you can figure out the other parts. And what if we couldn't use equivalent ratios? You could solve for the variable, but you want to make sure your variable is in the numerator. So how do you get your variable in the numerator? Let's go back to the original. So we have 5 over X is equal to the 25% is equivalent to Caesar salads. 25% is equivalent to 5 Caesar salads. That's why we can put them across from each other. Just like the whole is equivalent to X. So once we find out what X is, it's going to be the whole. Now, if we were to solve for the variable by getting a variable on one side of the equal sign by itself, since our variable is in a denominator, you do not want that, because if you move 5, first off, you would have to put 5 in the denominator. And that'll just be a waste of our time. So what we have to do to get X on one side of the equal sign by itself, so we don't have 1 over X, you want to get X in the numerator before you start doing anything. So you can solve, you can move x to the other side, but I'm just going to take the reciprocal of both sides. So the reciprocal of 5 over x is what? X over 5. And the reciprocal of 25 over 100 is equivalent to 100 over 25. So notice that my whole x is still equivalent to my whole percent, because that's what the equal sign means. And my 5 Caesar salads is still equivalent to my 25% that's equivalent to Caesar salads. Now that our variable is in the numerator, we can go ahead and solve for the variable by getting the variable on one side of the equal sign by itself. So since we have x divided by 5, we can use the inverse of division, which is multiplying, or we get 5 to cancel out. So we need 5 in the numerator since it's already in the denominator here. So 5 in the numerator is multiplying by 5. So if I multiply my left side by 5, I need to multiply my right side by 5 as well. Since I have 5 in the numerator and 5 in the denominator, it will cancel out, and I'm left with just x. Bring down my equal sign. I have 100. For my numerator, I have 100 times 5, which is 500. And then I have 25 times 1 for my denominator, which is 25. And once I divide 500 by 25, I'll get my final answer, 20. So this is how you can do it when you can't use equivalent ratios, or if it's too much thinking involved. You can solve for the variable, but you want to make sure your variable is in the numerator. Bruce collects stamps. He collected a total of 225 stamps. If 76% of the stamps he collected were foreign, how many other stamps did he collect? So it's two different ways you can go about answering this question. You really want to make sure you understand your formula. So the formula for percent is going to be part over whole, because percent is a part to whole ratio, and we literally want that denominator to become 100. So percent formula is going to be our ratio, our part to whole ratio, that we want to make equivalent to percent, where our denominator, or we want our denominator to become 100. So one side is going to be the ratio side, and the other side is going to be the percent side. So if we were to use the 76% right here, first off, let's substitute some information in. So what you have to understand for this question is that if 225 is the total, the whole percent is 100%. And 100% is equivalent to the total number of stamps, which is 225 stamps. If 76% is equivalent to foreign, so 76% is equivalent to the foreign, we don't know the number, but we know that 76 is the foreign stamps. This is the whole, the total. If we subtract the percentage, this will be the other. So part the whole is part to whole. So basically this will be the percentage, because the terms are going to stay the same. So if we subtract this, we have to borrow, this becomes a 10, then a 9, this becomes a 10. So we'll have a total of 24% is equivalent to other stamps. So you have to recognize, if you put 76% right here, the part that you'll get is equivalent to whatever the words is on this percent. Let me show you what I'm talking about. So if this is 76 and this 76% represents foreign, it can only be equivalent to foreign right here, because that's what the 76% is equal to. That's what the equal sign means. So if we were to solve for the variable using 76, that is not going to be the final answer, because the final question says how many other stamps. So you could substitute. So let's say we use x. We know the whole is 225. We put our equal sign. And if we use 76%, which represents the foreign, is going to be equivalent to foreign. So in the original problem, since 100 is equivalent to the total, That's why we set them across from each other, because that's what it equals. So 76% foreign is going to be equivalent to the foreign. So if we solve for the variable, this value for x is going to be equal to foreign, because that's what it was equivalent to in the original formula. So if I were to solve for the variable right here, or you can use equivalent fractions, I'm going to solve for the variable. So since I have x foreign coins divided by 225, I'm going to multiply both sides by 225. My variable is in the numerator, so it's good to go. I'm going to multiply both sides by the number that I'm trying to move, 225. The inverse of multiplication is division, and the inverse of division is multiplication. So since it says x foreign coins divided by 225, I know this is going to be the multiplication is the inverse operation. So since I have 225 in the numerator and 225 in the denominator, it will cancel out because its value equals 1. And now I have x, which is going to be the foreign coins, is equivalent to, once I solve, I'll get my answer. So I can put this over 1. And then I'm going to multiply my numerators across. So I'm going to multiply 76 times 225. And that's going to give me 17,100 for my numerator. 17,100. And for my denominator, I need to multiply 100 times 1, which is 100. And now I need to divide. It says 17,100 divided by, remember a fraction is a form of division, divided by 100. So I can just divide my numerator and denominator by 100. So I cross off these two zeros together. You can only do this with zeros because numbers work with the power of 10. And I'm going to cross off this 0. And now I have 171 divided by 1. So that's going to be my x, which is represented by foreign coins, is equivalent to 171. Now this is not the final answer, because in my original, x was equivalent to the percent that was foreign. So that means this x represents foreign. So if I want the other stamps, coins, which is 225 total stamps, if I take away the percent that is foreign, so minus 171, this is foreign. How do I know it's foreign? Because in the original it was equivalent to the foreign percent. So the x, when I solve for the variable, is going to be equivalent to the foreign part of the ratio. So once I subtract here, I'm going to get total minus foreign is going to give me other stamps. Now I have 5 minus 1, and I have to borrow here 54. So if you use this method right here, where you have 76%, you're using 76%, whatever is equivalent to that is going to be equivalent to foreign. Use this percentage in our formula. Instead of using 76% foreign coins, we will say x over the whole part, we don't know the part, out of the whole 225 is equal to the part percent. I'm going to put 24 right here instead of 76 over the whole percent, 24%. Remember, cent, that root word is 100. So now, since this 24% is represented by the other coins, and in the original equation, the equal sign means that this x is going to be equivalent to the other coins. So whatever the words is on the percentage is going to, if it's the equal sign is between them, the variable is going to have those words on it. So if we solve for the variable here, since x is equivalent to what we're looking for, the percent that we're looking for, you wouldn't have to subtract or anything here. So let's solve for the variable here. So I have x divided by 225. So if I want to solve for the variable x divided by 225, I will use the inverse of division, which is multiplication, and my variable is in the numerator, so I don't need to take the reciprocal. I'm going to multiply both sides by 225, and I can put that over 1 since it's a fraction. Since to change it into a fraction. Now, since I have 225 in the numerator and 225 in the denominator, it cancels out because anything divided by itself equals 1, just like 8 divided by 8 equals 1. So now on my right side, I just have x. I bring down my x other, x, which represents other, is equal to, I'm going to go ahead and multiply this. So I have 24 for my numerator, 24 times 225, 5,400. And for my denominator, I have 100 times 1, which is 100. And once I get my value for x, it says x is equal to 54. If you use this method right here, where you have 76%, you're using 76%, whatever is equivalent to that is going to be equivalent to 4. But if you subtract to get the other percent, which you subtract your percents, which you get 24%, and use 24% in your formula, it's going to be equivalent to others, and you won't have to subtract at the end. So whichever ever method you use, you're going to get the right answer, but you just know when you have to subtract, you have to pay attention to what your variable is equivalent to. So our answer is going to be 54. A storage tank is 20% filled with oil. The storage tank holds 1,610 gallons of oil. How many gallons of oil are needed to fill the storage tank? So we always want to know what we're trying to find. What are you trying to find here? The question mark is right here. The question word is how. So we're trying to figure out how many gallons of oil are needed. So that's what we're trying to find. Some given information to answer that question is the storage tank holds 1,610 gallons of oil. So is this the part or the whole? Remember, it's the formula for percent is percent is a part to whole ratio. So we know this is not the percent, not the whole percent or the part percent. But is this 1,610 gallons of oil a part of the whole? It says the storage tank holds. So if you have a storage tank, let's say we have a storage tank, and all that it can hold is going to be all up here. So this is the total. So the total in this case is going to be 1,610. The storage tank is 20% full. So if I take this is 100% full. If I take this 100% and divide it into 5 equal parts, let's do another one right here, and divide it into 5 equal parts, each part is going to be worth 20%. 20, 20, 20, 20, plus another 20 will give me my whole 100. So you could take this whole percent down to 20% to figure out and subtract, or you could just use your formula. So let's use the formula. So a percent is a part to whole ratio. So this is our ratio side that we want to make equivalent to percent per 100. So this is our percent side. So the number that we have here, now we can use 20% filled, or we can use 80%. So if the whole percent is 100, and the storage tank is 20% full, 20% oil right now, how much do you need to fill? So you need 80 more percent. This is what you need to fill it. You need 80%. So you can decide if you want to put 20% right here, or if you want to put 80%. If you put 20%, 20% is equivalent to what you have now. So it's not going to answer the question for what you need. If you put the 80% in, 80% is equivalent to what you need. So if you use 80%, it'll be equivalent to your final answer. So let's just do 20% because some people see 20% and they want to substitute it in. So we're going to put our part, which we don't know, over our whole, which is 1,610. The whole is equivalent to the whole percent. So if we use 20% right here, 20%, since this 20% represents what we have field right now, this is going to be what we have right now, not what we need. So have 20% is equivalent to what you have, x. So if we solve for the variable right here, let's go ahead and solve right here. I'm actually going to let's just solve for the variable. So I'm going to, since this says x divided by 1,610, I'm going to move 1,610 to the other side of the equal sign so I can have x on one side by itself. Now you can simplify this and use equivalent fractions, multiply both by 160, get an answer. But I'm just going to solve for the variable because some people have to learn when to multiply and when to divide. So now that I have 1,610 in the numerator and in the denominator, that's going to cancel out. And I'm going to be left with x, and x is what we have because it was equivalent to the 20% half. So I'm going to go ahead and multiply across. So I have 20 times 1,610, which is going to give me 32,200 for my numerator, and for my denominator 100 times 1, which is 100. Then I'm going to divide that because it says to divide by 100. So I'm just going to cross off this 0 with this 0, this 0 with this 0, and I have 322 divided by 1. So x, which represents what we have, not the answer to the question because the question asks for what we need, is equivalent to 322. Now if I want to figure out what we need, I'm going to subtract the total amount of gas, 1,610, total gallons that the storage tank can hold. If I subtract what we have, 322, from that, so this is the total, this is what we have, what we need is going to be the difference between these two. So I'm going to take 1,610 and subtract 322, and that's going to give me 1,288. So 1,288 is going to be actually what we need. Now, to eliminate the subtracting here or being confused, what you could do is substitute the 80%, since 80% is equivalent to what you need, you can just substitute that in right here from the beginning. So if I just go back and change, let's go back and change it. So now our whole is still going to be the same. 1,610 is still equivalent to the whole, 100%. But if I put the percentage that we need, which is going to be 80%, because it's the difference between the whole and what we have, if I put 80% right here, 80% represents the need. So if I put a variable right here and I solve for the variable is equivalent to the need percent. So the variable will be the actual amount that we need. So if I put 80% and solve for the variable, I'll get my answer. So I'm going to solve for my variable by getting x on one side of the equal sign by itself. My x is already in the numerator, so I don't need to move it to the numerator or take the reciprocal of both sides. Whatever I do to the right side, I'm going to do to the left side. This is going to cancel out. And now I'm left with x, which is represented by the need, is equivalent to, because that's what the equal sign means. So once I multiply, I'll get my answer here. So I have 80 times 1,610. That's going to give me 128,800 for my numerator, and for my denominator I have 100 times 1, which is 100. And then I'm going to divide. So this, since decimals work with the power of 10, or since I'm dividing by 100, I could just move my decimal point 2 times to the left, or I could just cross off these zeros. So now I have 1,288 divided by 1, which equals 1,288. So since the 80% was equivalent to the need, when I solve for x, it's equivalent to the need as well. So x is going to be what we need. So you can decide if you want to use the 20% or the 80%. This is question number 19 on the study guide. So we had this question on the warm-up. What you have to do here is you have to figure out, you have to complete this statement. So if 120 is equivalent to 100%, this 100% needs to be divided evenly into 1, 2, 3, 4 equal sections. So what I have to do here is I have to take 120 and divide it evenly into 4 equal sections to see what each section is worth to lead up to the 120. So 4 goes into 12, 3 whole times, 3 times 4 is 12. Bring down my 0. So we can conclude that each section is worth 30. So if I have 30 one time, that's going to be 30. If I have 32 times, that's going to be 60. If I have 33 times, that's going to be 90. And if I have 34 times, that's going to give me 120, my whole. Now I need to do the same thing for my denominator. So if I have 100 and I divide it evenly between 4 equal sections, 1, 2, 3, 4 equal sections, each section is going to be worth 25% because 100 cents divided evenly into 4 quarters is 25 cents. So this 25% one time is 25%. 25% two times or 2 quarters is 50%. 25% 3 times is going to give us 75%. 25% 4 times is the whole percent, 100. So since I have 1, 2, 3, 4, 5, I have 100 divided evenly between 4 equal sections, I can get my answer now. So each mark on the top number line increases by. So the top number line is going to be up here. The top number line is up here at the top. So the top number line is going to increase by 30. So the blank mark is 60. So if we come here, we need 30 2 times, so it's going to be the second mark. Each mark on the bottom number line increases by, when we took 100 and divided it evenly between the 4 sections, each section was worth 25%. So the 25% 2 times, because we had to go 25% 2 times to get 60, is going to give us the percentage 50. So we can conclude that 50% of 120 is 60.